What up, geometry students? Mr. Mester coming at you with assignment 1-1. We start fairly simple in concept. We're talking about line segments and points on line segments. And as you can read in the instructions, it says, how did it go yesterday? Yeah. Didn't you have your thing?
No, it's today.
Today's Thursday. Okay. It says one of the challenges in geometry is interpreting the problem and translating the information into an equation. Think about this as you work through the first examples. So we have this segment MP. We can see it on the side. We have this point N on the segment. Write an equation using MN, NP, and MP. So N is between M and P. We know it's on the line segment, but we don't know that it's like halfway. So a simple equation is that the line segment MN, its length, plus the length of segment NP equals the overall length of the segment MP. MN plus NP equals MP. And then we start involving algebra. Like, let's say we ask the question, if MN is 3 times a number, and P is 2 times a number, and MP is 20, what is the number? We can see in the question it says MN equals 3x, NP is 2x, and MP is 20. Substitute the known values into your equation. Well, it's like 3 times a number plus 2 times a number, 3x plus 2x. X is just replacing that concept of a number, equals 20. Well, if 3 times a number plus 2 times a number equals 20, many of you could probably figure out that the number has to be 4, or we can use algebra. And we could say, well, we would have 5 times the number, same side of an equation you are able to combine like terms. And then if 5 times the number equals 20, we know that number has to equal 4, whether you just know by looking or you know by dividing. Undoing what is being done to the unknown to reveal the unknown's value. Great. And that's actually what I did here, as I did those steps here. Use your equation to determine the lengths of M, N, and NP. So I know what the number is. The number is 4. Well, since MN is 3 times the number, MN has to be 3 times 4, which is 12. Since NP equals 2 times the number, NP has to equal 2 times 4, which is 8. Great. So that's the idea about all of these questions, is we are going to have like a geometric situation, a simple geometric situation, but we're going to be revealing lengths using algebra. In the next question, we have assuming point B is on the segment AC, and we are told AB equals 2x plus 3, and BC equals x minus 3. Then part A says if AC equals 14, is B the midpoint of segment AC? Explain. So we're trying to figure out, is B the midpoint? We learned in class that midpoints just means we split the segment in half. So let's try to reveal the lengths of AB and BC and see, will they be equal to each other? So we have another setup where the segment AB plus the segment BC has to equal the segment, the overall segment AC. And then we can replace. AC is 14. AB, we are told, is 2 times a number plus 3. BC is a number minus 3. We can then use algebra to reveal the missing number. Same side combine. 2x plus x is 3x. 3 minus 3 is 0. We have the equation 3x equals 14. X equals 14 14 thirds. Okay, so now we have to think to ourselves, is AB, which is 2x plus 3, going to equal BC, which is x minus 3, when x or a number is 14 thirds. So we have to do a little bit of math here with fractions, and hopefully we're going to be okay with it. 2 times 14 thirds, I'm doubling 14 thirds. I have 28 thirds, or 2 times 1 times 14 over 3, multiply across. I like to just think about it more like thirds are types of units. Like I have 14 of these thirds, so now I have 28 of these thirds. What's 3? Well, in terms of thirds, 3 has to be 9 thirds. How we do this mathematically is multiply the top and bottom of 3 over 1 by 3 over 3 to get that 3 is equivalent to 9 thirds. 28 thirds plus 9 thirds is 37 thirds. We'll do that again, 14 thirds minus 9 thirds. And we can just see immediately that this is not going to be the same. I'm sure there are many other ways to confirm that this is not, these two segments are not the same. Like plug in any value. I could have said like, can 2x plus 3 equals, okay, that's going to be the next thing we do. So I'll pause there. So BC is 5 thirds. We can see AB does not equal BC. Therefore, M is not the midpoint. AB does not equal BC. Now, another way to have confirmed that M is not the midpoint is kind of laid out for us in part B. For what value x would AB equal BC? Well, if AB equals BC, that means the number has to follow the properties where 2 times the number plus 3 equals the number minus 3. Now, we have variables on both sides of the equation. We have unknowns on both sides. We can use algebra to help us figure this out. I'm going to take away an x from both sides. So I have x plus 3 equals negative 3. And then to solve for x, I should be subtracting 3. And I see this number has to be negative 6 for that to be the case. Now, this is like something that we could have. We could have an answer that is a negative number, but then produces positive segment lengths. But we don't like to say that any lengths are negative. So we can kind of see that it's not gonna work. Why does it not work? You can see why does it not work? Well, BC would equal minus 6 minus 3, which is minus 9. That doesn't make sense. A negative length I don't like that. And then for AB, you could do the same thing. Negative length does not compute. All right, popping over to the second side, we are on question number 3, and we are told to sketch the diagram ourselves, whether it's in your brain or on the paper. We are not providing as much information. You're going to have to set up the equations. You're going to have to draw the situation. So we start with 3a, which is a simple one. We have point X on the segment between points A and Z. So you can think about a segment AZ, and you can think about X being somewhere between A and Z. I'm going to also read that AX equals 6 and AZ equals 20. So I'm going to put X closer to A, knowing that AX is 6, and then XZ is 20. We can see that AZ is 20. Sorry. labeling things the wrong way. Read carefully. AX is 6, AZ is 20. What is the missing length? Well, I have AX, I have AZ, I'm missing XZ. Well, how do I figure out XZ if AZ is 20 and AX is 6? Hopefully you're thinking we need to subtract because AX plus XZ has to equal AZ because AX is 6. AZ must be 14. Sorry, XZ must be 14. Cool. Point M is the midpoint of segment DW. DM is 2x plus 1. DW is 15. So they're giving me segment DW, and M is smack dab in the middle. DW is 15. DM is 2x plus 1. Well, how do we work on this? Well, we could subtract, but the problem is I can't really set up an equation right now because I'm not going to be able to get a number. Like I can't say this is 2x plus 1 plus MW equals 15. Doesn't really work. There's too many unknowns. So we have to read carefully and understand that knowing that M is the midpoint of the segment DW, you should know that DM and MW are the same. So MW has to be also 2x plus 1. And now we have the situation of DM plus MW or 2 DMs has to equal DW. Or 4x plus 2 equals 15. Now, let's reveal the missing number by subtracting 2 and then dividing to get the missing number. This x number which has to be 15/4. Or you know DM has to be 7.5. That's another thing you could have done. Why did I do that thing when I could have done this? Yes, multiple things to do. I could have said 2x plus 1 equals 7.5. Why do I know that? Well, because we know the entire line segment is 15. Half the line segment has to be 7.5. Now that's 15 halves. Why don't we just say that that's 15 halves and watch how you could solve this equation. 2x plus 1 equals 15 halves. I can subtract 1. That's subtracting 2 halves from the 15 halves. The divide by 2. Dividing by 2 is like halving. If I have 13 halves and I cut them in half, I get 13/4. Why did I make a mistake over here where it should have been 13/4? I'm sorry, I forgot to subtract 2 and write that this is 13. So, my bad. I will be making plenty of mistakes as I make these videos, as they are live. All right, some more. Point P is the midpoint of segment RO. So picture that. If RP is equal to 8 units, RO is equal to 5 more than 4 times a number, what is that number? It's a very good question where we have to pay attention to details. We're not doing the same thing every single time. We're ready to adjust and adapt, think mathematically. Well, let's read it again. Point P is the midpoint of segment RO. RP is 8. RO is 5 more than 4 times the number. Now, 5 more than 4 times the number, I'm immediately saying 5 more than 4 times x. I'm using x as a replacement for this concept of a number. This is algebra. Well, RP is 8. That means PO has to be 8. That means RO has to be 16. We have this 5 plus 4 times a number equals 16. We know that 4 times the number has to equal 11 just by backing things out. And we reveal the numbers missing value 11/4. For 8, that's 2 3/4 if we want to do that. But we don't like mixed numbers in geometry, so we're going to keep things as 11/4 or change it into a decimal. Okay, part D, point O is on a segment between G and V. So we have this point O between G and V. I don't know where O goes. I'm not going to assume it's in the middle. GO is 4 less than 3 times the length of OV. GV is 24. Let's read that again. GO is 4 less than 3 times the length of OV. GV is 24. How do I set this up? Well, I can assign OV some length x, some number. I know GO is 4 less than 3 times the length of OV. So 3 times x minus 4 would be an expression for GO. OV is x, GO is 4 less than 3 times OV. Well, if OV is x, 3x minus 4 is GO. Now we've set up the idea of GO, 3x minus 4, plus OV equals GV. If 3x minus 4 plus x equals 24, 4x minus 4 equals 24, which we can then back out what's being done to this missing number by adding 4 and then dividing by 4 and realizing the length 4 is 7. So OV is 7. I didn't really ask you what to find. I guess you're finding all the missing lengths. So OV is 7. And GO has to be 24 minus 7, which is 16. No? 17? 17. All right, last two. Point P is on a segment between AC. Point B is on a segment between the points A, C. AC has a length of 8. If AB is 4 less than half BC, what is the length of AB? If AB is 4 less than half BC, what is AB? Okay, well, I will say 1/2 of a number minus 4 can be an expression for AB, 1/2 x minus 4, and BC can just be represented by x. And now I have an equation that I can set up and solve. 1/2 x plus 4 plus x is 8. 1/2 of an x plus an entire x is 1.5 x's. I'll write it as 3/2 x's. 1 plus 1/2, this is 2/2 of an x plus 1/2 of an x. 3/2 of an x minus 4 equals 8. Add 4 to both sides. 3/2 in an x equals 12. 3/2 of a number equals 12. What's the number? Well, we could divide by 3/2. 12 divided by 3/2. Dividing is the same as multiplying by a reciprocal. So turns out if I find 2/3 of 12, I will reveal the number where 3/2 of the number is 12. Think about that as working out. Like if I divide 12 by 3/2, I'll be able to figure out the number 3/2 is multiplied to get 12. Same as multiplying 12 by 2/3 will reveal the number times 3/2 to get 12. Okay, 12 times 2 is 24. I'll have 24/3. Or if you forget multiplying fractions, we multiply straight across, and that kind of is the formulaic way that we get 24/3. And guess what? 24/3 is 8. So that means BC is 8, and AB is 1/2 of 8 minus 4. 1/2 of 8 is 4. 4 minus 4 is 0. point B is between A and C is a false statement. Turns out the way that this question was set up, B is on A. We wouldn't ask you this question for a quiz. It should have been probably reworded. Is this possible? Is this possible? And if you could think about other reasons why this can't be possible, that's great. Last question. M is on a segment between L and N, hopefully. M is on a segment between L and N. ML is 2 more than a third of LN. Ooh. MN is N18. What is LN? So this is probably the hardest one here because LN equals a number. ML is 2 more than a third of LN. MN is 18. This is a great question where you have to understand and read carefully and have the correct setup because we're not going MN is X and then LM is 2 plus a third of X. We are saying 2 plus a third of X plus 18 has to equal this length of X. Let's see if we get a good answer here. 2 plus 18, which means a third of X plus 20 is X. Cool, well, I'm going to subtract a third of an X from both sides. I'm trying to reveal the missing number. And I get 20 equals, if I have one X and I subtract a third of an X, I have 2/3 of an X. If you want to use algebra, you could say 3/3 is the same as 1X. 1X minus a third X is 2/3 X. And now 2/3 of a number equals 20. That means either 20 divided by 2/3 is our missing number, or 20 times 3/2. That's 60 halves, that's 30. That works out perfectly. So that means MN is 18. LM will have to be 12. So that 12 plus 30 equals 12 plus 18 equals 30. I love that question. That's my favorite question of the day. Probably do more questions like that. Warming up for next class. Hope you enjoyed this first video. If you watched it, please come in with questions. And if any of these problems were tough for you, any of these problems you're like, I have no idea what I'm doing, then you need to do more practice. Please come into the math office, see any teacher, show them the question that you're struggling on, and we'll give you more practice problems on that type of question. Peace.